So the important code that I changed that helps the tank move more fluidly and helps it go over hills and stuff is starts right here. So float left average equals 0, and then the rest of that. This is initializing the accumulators to store terrain heights for the left and right wheels individually rather than just calculating it based on terrain height. Then we have this for loop here, and using int I, when I is basically less than the number of wheels per side. This is going to just apply that for apply these for each wheel, and this is it's gonna loop through the wheels, and it's going to plus the terrain heights together, basically for a better coordinate fit and roll like direction. And those two lines in each loop are converting the total height into basically an average height for each side. So then we have float equals roll math 2 degrees, and then this calculation here. This is calculating the roll angle in degrees. This is by comparing the difference of the average wheel heights across the tank width. And then we have the body tank height. This is going to just define the tank of the height of the body. Then we have calculating half the body height to the center of the body, basically having a midpoint. Then we have push matrix. This is just saving the current matrix state for OpenGL purposes. Then we have translate, which is moving the tank body to the correct XY position and raises it to the average terrain height plus the Y offset, basically. Then we have the GL rotate, which is going to tilt the tank based on the left or right terrain. And then we have the GL rotate with the pitch. It's going to tilt the tank body forward or backward, depending on the incline, which is one of the main things that needed to be fixed. Then we have render tank body. This is going to draw the 3D model for the tank. Render turret. This was unchanged technically. That was team code. So yeah, the wheels was another important thing that I changed to help them not just move up and down randomly. So for this iteration loop right here, we have for each wheel, it's going to calculate the Z offset relative to the tank center, and then it's going to save the current transformation state for the left wheel. Then it's going to apply roll tilt, and it's going to apply a pitch tilt as well. And then it's going to offset the left side of the tank and down to the wheel's local position, and it's not going to calculate it based off the terrain height anymore. And then it renders the wheel. Thank you, Dr. Sanders, and I'll see you in class.